Hello! Today we're going to explore the fascinating world of square roots. By the end of this video, you will be able to, first, understand the connection between rational exponents and square roots. Second, you'll be able to classify numbers as either rational or irrational. And most importantly, you'll learn a powerful method to calculate the square root of any positive number. Let's begin with a quick recap of rational exponents, also known as fractional powers. A rational exponent is simply an exponent that is a fraction. For example, a number raised to the power of 1/2. We write this as x to the power of 1/2. This notation is directly related to roots. Specifically, raising a number to the power of 1/2 is the same as taking its square root, so x to the power of 1/2 is equal to the square root of x. This means that the square root symbol is just another way of writing a 1/2 exponent. Let's look at an example. What is 25 to the power of 1/2? Using our rule, this is the same as the square root of 25. The square root of a number is the value that, when multiplied by itself, gives you the original number. In other words, we're looking for a number that, when squared, equals 25. Since 5 times 5 is 25, the square root of 25 is 5. So 25 to the power of 1/2 is 5. This connection between fractional exponents and roots is a fundamental concept in algebra. It shows that roots are just a special type of exponent. Now let's recap how to find the square root of a perfect square using prime factorization. A perfect square is a number that is the square of an integer, like 4, 9, or 16. Let's find the square root of 144. First, we find the prime factorization of 144. This means we break it down into its prime number components. 144 is 12 times 12. 12 is 2 times 6, and 6 is 2 times 3. So, 144 is 2 times 2 times 3 times 2 times 2 times 3. Next, we group the prime factors into pairs. Remember, we're looking for a number that, when multiplied by itself, gives 144. We have a pair of 2's, another pair of 2's, and a pair of 3's. For each pair, we take one of the numbers. This is because the square root of a number squared is just the number itself. So we take 1, 2 from the first pair, 1, 2 from the second pair, and 1, 3 from the third pair. Multiplying these together, we get 2 times 2 times 3, which is 12. So the square root of 144 is 12. This method works perfectly for perfect squares because all the prime factors will form pairs. But what happens when they don't? This brings us to the distinction between rational and irrational numbers. This is a crucial concept in mathematics. First, let's define a rational number. A rational number is any number that can be expressed as a simple fraction, p over q, where p and q are integers and q is not 0. This includes all integers, like 5, which can be written as 5 over 1. It also includes terminating decimals, like 0.75, which is 3 over 4. And it includes repeating decimals, like 0.333, which is 1 over 3. So, integers, terminating decimals, and repeating decimals are all rational numbers. Now, let's define an irrational number. An irrational number is a number that cannot be written as a simple fraction. When written as a decimal, it is non-terminating and non-repeating. The digits go on forever, without any pattern. The most famous irrational number is pi, which starts 3.14159 and continues infinitely without repeating. Another example is the square root of 2. The square root of 2 is approximately 1.41421356, and its decimal representation never ends and never repeats. This makes it an irrational number. So the key takeaway is this. The square root of a perfect square is always a rational number. But the square root of any other positive integer is always an irrational number. For example, the square root of 9 is 3, which is rational. But the square root of 10 is irrational. It's a number that can't be written as a simple fraction. This means that for most numbers, we can't find their square root exactly. We can only find an approximation. But how do we find a good approximation? That's what we'll learn next. Today, we're going to learn a powerful method for calculating the square root of any positive number, whether it's a perfect square or not. This method is called the long division method. It's a step-by-step process that looks a lot like long division, but is designed specifically for finding square roots. Let's walk through the steps with our first example, the square root of 17. First, we set up the problem. We write 17 under the square root symbol, and we'll write our answer, the square root, on top. Step 1 is to group the digits of the number into pairs, starting from the decimal point and moving left. For 17, we only have one pair, 17. Step 2 is to find the largest perfect square that is less than or equal to our first group, which is 17. The perfect squares are 1, 4, 9, 16, 25, and so on. The largest one less than or equal to 17 is 16. Step 3 is to write the square root of that perfect square, which is 4, on top. This is the first digit of our answer. Then, we write the perfect square, 16, below the 17 and subtract. 17 minus 16 is 1. Step 4 is to bring down the next pair of digits. Since we don't have any more digits, we add a decimal point to our answer and bring down a pair of zeros. This allows us to find a more precise answer. Step 5 is to double the number on top, which is 4, to get 8. We write this 8 down, leaving a space next to it. This will be the start of our next divisor. Step 6 is to find a digit to put in that space, and also on top, such that when you multiply the new divisor by that digit, the result is less than or equal to 100. Let's try 1. 81 times 1 is 81. If we try 2, 82 times 2 is 164, which is too big, so 1 is the correct digit. We write 1 on top and in the space. Then we multiply 81 by 1 to get 81, write it below 100, and subtract. 100 minus 81 is 19. We can continue this process to get more decimal places. Let's do one more step. Bring down another pair of zeros. Double the number on top, 41, to get 82. Find a digit, x, such that 82x times x is less than or equal to 1900. After some trial and error, we find that 2 works. 822 times 2 is 1644. We write 2 on top and in the space, subtract, and get a remainder of 256. So we found that the square root of 17 is approximately 4.12. This method allows us to find the square root to any desired level of precision. Let's try another example to solidify our understanding. This time, let's find the square root of 89. First, we set up the problem. We group the digits into pairs. For 89, we have one pair. Next, we find the largest perfect square, less than or equal to 89. The perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. The largest one, less than or equal to 89, is 81. We write the square root of 81, which is 9, on top. We write 81 below 89 and subtract. 89 minus 81 is 8. Now, we bring down a pair of zeros. We double the number on top, 9. To get 18, we need to find a digit, x, such that 18x times x is less than or equal to 800. Let's try 4. 184 times 4 is 736. If we try 5, 185 times 5 is 925, which is too big. So 4 is our digit. We write 4 on top and in the space. We multiply 184 by 4 to get 736, write it below 800, and subtract. 800 minus 736 is 64. Let's find one more decimal place. Bring down another pair of zeros. Double the number on top, 94, to get 188. We need to find a digit, x, such that 188x times x is less than or equal to 6,400. After some calculation, we find that 3 works. 1883 times 3 is 5,649. We write 3 on top and in the space. We multiply 1883 by 3 to get 5,649, write it below 6,400, and subtract. The remainder is 751. So, the square root of 89 is approximately 9.43. Notice how the process is identical to the previous example. Once you learn the steps, you can apply them to any number. Finally, let's tackle an example with a decimal. The process is almost the same, but we need to be careful with how we group the digits. Let's find the square root of 432.5. The most important step here is grouping. We group digits in pairs from the decimal point. To the left, we have 4 and 32. To the right, we have 5. We need a pair, so we add a 0 to make it 50. So our number becomes 432.50. The groups are 4, 32, and 50. We'll start with the first group, which is just the digit 4. The largest perfect square less than or equal to 4 is 4 itself. The square root of 4 is 2. We write 2 on top, subtract 4, and get a remainder of 0. Now we bring down the next pair, which is 32. We double the number on top, 2, to get 4. We need to find a digit x, such that 4x times x is less than or equal to 32. If we try 1, 41 times 1 is 41, which is too big. This means our digit must be 0. We write 0 on top and in the space. 40 times 0 is 0. We subtract 0 from 32, leaving 32. We've reached the decimal point in our number, so we place a decimal point in our answer on top. Then, we bring down the next pair, 50. Double the number on top, 20, to get 40. We need to find a digit, x, such that 40x times x is less than or equal to 3,250. After some trial and error, we find that 8 works. 408 times 8 is 3,264, which is slightly too big, so we must use 7. We write 7 on top and in the space. We multiply 407 by 7 to get 2,849. Write it below 3,250 and subtract. The remainder is 401. So, the square root of 432.5 is approximately 20.7. The key difference with decimals is the initial grouping of digits, but the rest of the process remains the same. Let's quickly recap what we've learned today. We started by connecting rational exponents to square roots, showing that x to the 1/2 power is the same as the square root of x. We then explored the difference between rational and irrational numbers, learning that the square root of a perfect square is rational, while the square root of any other positive integer is irrational. Finally, we learned the long division method, a powerful algorithm for finding the square root of any positive number to any desired precision. We saw how to apply it to integers and decimals. This method is a great tool to have, especially when you need to find a square root without a calculator. Now for some practice, here are 2 homework problems for you to try. First, find the square root of 121 using prime factorization. Second, use the long division method to find the square root of 50 to 2 decimal places. Take your time, follow the steps, and you'll get there. Thank you for watching, and I hope this has helped you understand square roots better.